Right, let's have a look at the group 1 metals. So the group 1 metals are called the alkali metals, okay? And here they are in group 1 of the periodic table. So we start with lithium at the top, then sodium, then potassium, then rubidium, then cesium, and then francium. The group 1 metals form 1+ ions, okay? So what you can see here is this outer valence electron will be lost quite easily, and it'll form the Na+ ion. Okay, and that's a +1 ion there. And this is true of all the elements in group 1. They all make 1+ ion by losing the outermost valence electron. The second point, group 1 metals form ionic bonds. Okay, so ionic bonds are bonds between metals and non-metals. An example would be sodium reacting with chlorine gas, and we look at some of those examples later. Okay, the physical properties of group 1 metals. They have very low density. Lithium, sodium, and potassium will float on water. The atomic radius, the size of the atom, increases down the group, and that's because we have more filled energy levels. The melting point decreases down the group, and that's because of a weaker metallic bond as we go down the group. Okay, chemical properties of the group 1 metals. Group 1 metals are very reactive. They are stored in oil to prevent the reaction with oxygen in the air. If you have a group 1 metal in air, it's so reactive it'll react with the oxygen in the air, so they keep them in oil. The reactivity increases down the group, and one of the reasons is because ionization energy decreases down the group. Okay, so the trend is we have least reactive at the top, most reactive at the bottom. Okay. Right, so here's some more general information about the group 1 metals. We have electron arrangement here. Okay, you can see they all have 1 on the end, which means they have the 1 valence electron in the outer shell. You can see the melting point is decreasing from left to right. We have increasing atomic and ionic radius, we have decreasing ionization energy, and we have decreasing electronegativity. Okay. So the reaction with water. Group 1 metals react vigorously with water to produce the metal hydroxide and hydrogen gas. So in this picture at the top you can see a group 1 metal being dropped into water, and it reacts very vigorously. Here's the general word equation for sodium. So sodium plus water makes sodium hydroxide plus hydrogen. But we'll have to write these as symbol equations. So here's the balanced symbol equation. 2Na plus H2O gives you 2NaOH plus H2. Okay? Another example for lithium. Okay? All you have to do is change the group 1 metal. Everything else is the same. The coefficient is the same, 2 and 2, and of course hydrogen gas is produced in both reactions. Now the resulting solution will have a pH of 14. Okay, that means universal indicator will change to purple because we are producing sodium hydroxide or lithium hydroxide. These are strong bases. Okay, they dissociate completely in solution to give you the OH negative or hydroxide ion. Okay, because they're strong bases, they'll have a high pH in solution. And the last thing is reaction with group 7 elements. So group 7 elements are things such as chlorine and bromine and iodine. Okay, so here we have sodium reacting with chlorine to give us sodium chloride, lithium reacting with bromine to give us lithium bromide, and potassium reacting with iodine to give us potassium iodide. And all these compounds are ionic compounds, okay? So that means they're made of a metal and a non-metal, okay? And they're also called salts. So those are the reactions of group 1 metals with group 7 elements, and that's it.